Hey guys, Mr. Mailhot here. I just wanted to review our foldable in case you were gone and you wanted to get copies. So follow along, pause the video if you need to get down notes. You could do these on regular note paper, or you can, cut up a foldable kind of like this. It's got three flaps on both sides. Cut one up or just take notes. Here we go. Let's talk about even functions first. I'll go fast. Again, pause if you need to. Even functions. The first big thing, they're symmetric around the y-axis. That means if you're looking at a graph and it's even, you could spin it around the y-axis, almost like a top. Like you could spin it like that, and it'd work. Parabolas are nice examples if they're centered around the y-axis, but also, ones that look kind of funky like this. If I spun that around, both these arrows would still be facing up. That would still be pinned at the bottom. Those are symmetric, even. Here's a more solid example, x squared plus 3. Been shifted up 3, but heck yeah, if you spun it that way, it'd be even. Now also, not only are they even if it's symmetric about the y-axis, if all of the exponents are even, only even, you're good. And in fact, there is an exponent on this 3. Remember, there's that sneaky x to the 0 power that we don't ever write because x to the 0 equals 1, and 3 times 1 is just 3, so we just write the 3, but 2 and 0 are even, so even. All right, let's look at odd. Odd functions. Remember, the O is going to help us remember some stuff. Odd functions, well, one thing, they're symmetric about the origin. If you're looking at a graph, not spinning it like the even functions, not like this, not like that. No, 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 no. But if you could twist it, right? Twist it around. Or I even think of pin it at the origin with your pencil and spin it around one time like that, twist it like that. Does that look the same as what we started with? Yeah, pretty much, right? You go right back. Yeah. Pointing up here, pointing down over here. Heck yeah. Here's a graph example. X to the third minus x. It looks something like this, and look, only even exponents. Remember, if you have just an x, there's an x to the first. So both, sorry, I said even, both odd. Only odd exponents, right? Odd function, O. Origin, O. Only odd exponents, O. We're good. Now, graphs could be neither even or odd, right? If they're not symmetric. If you can't twist it or can't spin it, then they're not even or odd. Any of those would work fine. An example would be a linear, like 2x minus 3. This is an odd exponent. This x to the 0, even. You got a mixture, even and odd, neither even or odd. It's a combo of both. It's neither. Okay. Here's where it gets a little more detailed. We got to get to the pre-calculus level of understanding. Here's the algebraic proof of how it works. If you plug in a negative x and the function doesn't change, that means it's even. For example, take something like this, 3x squared plus 2. It'd be a parabola, we could graph it. Look, it has only even exponents, that's great. It's even, but let's prove it by plugging in a negative x, which means you also plug in a negative x here. Now, negative x squared means negative x times negative x. Negative times a negative is just positive, and x times x is still x squared, so negative x squared is the same thing as x squared. It'll become positive. The function is the same. Look, what we started with right here, is the same as what we ended with down here when we plugged in our negative x. Same, even. Odd. Again, the O's are kind of helpful. If you plug in a negative x, the function becomes opposite, or you kind of multiplied by a negative. Opposite. Here's an example. X to the 7th plus 2x to the 3rd minus x to the 1st, right? They're all odd, so you're thinking it's an odd function. Prove it. Plug in a negative x here, here, and here. Simplify. Okay, negative x to the 7th. negative x in parentheses to the 7th. If you're multiplying a negative number by itself an odd number of times, it's going to come out negative. Right? If you do negative 1 times negative 1 times negative 1, that's 3 times. 1, 2, 3. These two times each other will be positive, times another one will be negative. And if we do it again, times 2 more negative 1s, there's another positive, so positive, positive, and a negative again. So negative exponent on or odd exponent on a negative base will become negative. Still has the exponent though, just like here. Odd exponent on a negative base, opposite. Odd exponent, yes, it's odd, there's a 1 there. Odd exponent on a negative base, opposite. Right? Minus a minus x is a plus x. Opposite of our original function. Take a look. We had plus or positive x to the 7th, positive 2x to the 3rd, negative x, right? Positive, positive, negative. And when we plugged in negative x, we got out not positive, positive, negative, but negative, negative, positive. Look, they're opposites. Right? They're opposites. Opposites, odd function. Now neither, pretty straightforward. When you plug in a negative x, who knows what you're going to get out. But if it's neither, it's not going to be one of these. Because if it's this, well then it's odd. And if it's this, then it's even. If it's neither one, well then it's neither odd or even. Even or odd. Example, 2x to the 5th plus x to the 4th. Right? You got odd and even exponents. So you're thinking it's a combo, it's neither. But when you plug it in, look, there's your negative, there's your negative. Odd exponent, negative base, opposite. Even exponent, negative base. Holy cow! Changes. It changes. I'm misspeaking. How do I say this? Negative x times negative x would be a positive x squared, right? Negative times negative. This to the 4th power just has you do it 2 times. Notice that these aren't complete opposites, and they're not the exact same. The first term became negative, the second one stayed the same. It's neither the same or exact opposite. It's neither. Okay, stay tuned for a video here real quick for some examples. See you later. Remember, we're mathematicians. We can do anything we want.